Another important form of defense is to make use of networking features such as firewalls, IP whitelisting, and virtual networks to secure your microservices. In this diagram, we can see three microservices communicating with each other. And if we can place them inside a virtual network, then we have the ability to reject any incoming traffic from outside the virtual network and only allow them to communicate with each other. And this type of approach is a great idea to help protect your back-end services, which may need to communicate between themselves, but you don't necessarily need access to them from outside. But what about those situations where you do need to accept traffic from the internet? For example, if you've got a website implemented as a single-page application, then it will want to make requests to your microservices. So does that mean you have to forego any kind of network restrictions and just open everything up? Well, this is actually an example of where the pattern that we discussed earlier in this course, the API gateway or backend for front-end, can be really helpful. We can have an API gateway that accepts incoming requests from the public internet, but is also connected to the virtual network, and so is able to pass on incoming requests to the backend microservices. And this means we can be very selective about exactly which backend APIs are able to be called from the outside. It also means that we've got a single point of entry. Some cloud API gateways can also be configured with a firewall or other types of attack protection, such as guarding against distributed denial of service attacks or SQL injection attacks. Often in a microservices application, there's a public-facing website, like the eShop on Containers store website. But there may also be additional websites intended for use by a smaller targeted group of users, such as system administrators. For example, the eShop on Containers application supports creating marketing campaigns, which are sent out to customers by email. And if there was a marketing website that allowed them to create these campaigns, the only people authorized to access that website are staff from our company. So we might decide to apply IP address whitelisting so that this website rejects any traffic that doesn't come from certain known IP addresses, such as the IP addresses of the marketing offices. Now, so far in this module, we've talked about quite a few different techniques for securing our microservices. And you might be wondering whether you need to use all of them or whether you can just pick one or two. And this is where the defense in depth principle comes in. This principle encourages us to avoid relying solely on a single layer of protection and to use multiple layers of security wherever possible. So let's discuss the idea of defense in depth in a bit more detail. We've discussed a number of techniques in this module to secure our microservices. By using encryption in transit with TLS, the traffic to and from our microservice can't be listened into by unauthorized third parties. By using access tokens issued by an identity server to authenticate ourselves in the requests, our microservices can reject any incoming calls from unauthorized clients. And by using virtual networks and IP whitelisting, we can reject any calls to our microservices that come from an unauthorized network location. And the defense in depth principle states that you shouldn't rely entirely on a single technique to secure your application. And that's because if that one defense is breached, then everything is lost, and your attacker has gained free access to everything. So by combining several different layers of security, we can significantly reduce the possibility of a data breach. And the more sensitive the data that you're dealing with, the more important it is that you apply several layers of protection. And certainly these three techniques that we've just discussed, I would consider to be essential for securing any microservices application that deals with sensitive data. But there are some additional defensive measures that we can take. For one thing, modern hackers have a variety of very sophisticated tools and techniques at their disposal. And so often software developers aren't aware of all of these attack techniques and don't have the knowledge of how best to mitigate against them. And for that reason, it's a very good idea to arrange for penetration testing to be performed by a team of InfoSec experts who can test the defenses of your application against state-of-the-art hacking techniques, and can also give you some expert advice on how to increase the security of your applications. I also recommend that you create automated tests that verify that your security is working as expected. Don't just assume that you've configured your virtual networking or access token validation correctly. Run some tests that prove that unauthorized users are not able to call your APIs. It may also be possible to detect when an attack is in progress. Port scanning, repeated login attempts, HTTP requests phishing for sensitive files, SQL injection attack attempts, all of these things can be detected in real time, and you should configure alerts so that you know when they're happening. And this allows you to proactively make the decision either to block traffic from the attacker's IP address, or maybe even to temporarily shut down part of your system to protect against the attack. Finally, you should have good logging and auditing of all of the actions being performed in the system. This way, it's possible to review exactly who did what and when they did it. And that way, if there is a data breach, you'll have a much better chance of understanding how it happened, as well as exactly what data has been compromised. Securing our microservices should be one of our highest priorities. The stakes can be very high when you're working on a system that deals with sensitive data. And that's why in this module we emphasized a defense in-depth approach. And the techniques that we should consider applying wherever possible include encrypting data in transit with TLS, encrypting data at rest in files and databases, authenticating users, ideally by means of industry-standard protocols such as OAuth 2 and OpenID Connect, and ensuring that we also correctly authorize access to our microservices so that users can only perform the actions that they have permission for. In addition, we can configure various network-level security, such as virtual networks, IP address whitelisting, firewalls, and making use of API gateways that can create a single point of entry for external traffic. It's also a great idea to make use of security experts to perform penetration testing and provide feedback on our system design. And we should configure alerts for attack detection and regularly review the system audit logs to identify any suspicious access patterns or behavior. In our next module, we're going to look at how we can deliver microservices, focusing in particular at the challenges of deploying and monitoring our microservices.